Hello and welcome to lesson 10.1, and in today's lesson we are going to be multiplying and dividing rational expressions. So first we're going to start with simplifying rational expressions, then we will multiply and divide and of course simplify the rational expressions. So we haven't covered rational expressions yet this year, so let's talk about them. A rational expression is the ratio of two polynomials. Rational expressions can be simplified and combined using the operations of addition, subtraction, multiplication, and division. Writing rational expressions in simpler forms and combining them will help you to understand and graph rational functions and solve equations. That'll be coming up in Activity 11. To simplify a rational expression, you want to factor the numerator and the denominator, identify restrictions on the variable x that make the denominator in the expression equal to 0, then divide out the common factors. The variable in a rational expression must be restricted so the denominator does not equal 0. Okay, so just like we restricted in square roots, we want to restrict in rationals as well. All right, so there's a couple examples that we'll go past and then we'll go into some of the try these so I can show you how to do this. So simplify, and then we'll identify any restrictions. And of course, we'll show all of our steps. Okay, so for part A, we have, in the numerator, we have x squared plus 20x plus 36. So we can factor that. Okay, so I do really good at factoring here. So I need two numbers that multiply to 36, but add to 20. And so if we think about those two numbers, 36 has a lot of factors, but I believe it's going to be x plus 2 and x plus 18. And 18x plus 2x is 20x, and 2 times 18 is 36. Now, on the bottom, we are factoring x cubed minus 4x, so we can take an x out. That's a GCF. And that will leave us with x squared minus 4. Well, now we know that x squared minus 4 is a difference of squares, so we actually can do one more factoring step on that one. All right, so on top I have x plus 2, and I have x plus 18. On the bottom, I have x, but then I have x plus 2 and x minus 2. Okay, so we factored. Now we can divide out any common factors, which we have a couple. So we're going to divide out the x plus 2 and the x plus 2. And so what we have left after we're done dividing out, we have an x plus 18 on top, and on the bottom we have x times x minus 2. Okay, so that's the simplified expression. So that's what we want to do first, is to simplify the expression. But then when we're all done, we want to think about what numbers would create a 0 in the denominator. And so we want to think about setting the denominator equal to 0. So it's best to do that when you have the, after you have it all the way factored out. And so what we want to do is, if we look at x times x squared minus 4, before we do any canceling, okay? So if I look at before we do any canceling, we have an x plus 2, and an x minus 2. And you think about when each of those would equal 0. So the x would equal 0 when x is 0. So one of our restrictions is going to be when x equals 0. Let's write it like this. So we'll say our restrictions are x equals 0. So x cannot be 0. It's also if x were 2. And finally, if x were negative 2. So before we do any canceling, we look at the bottom. And so that really occurred like right here. And you think about what would make each one of those quantities equal to 0. And those would be considered your restrictions. So let's try another one. And let's go to part B. So in part B, I have, on top, I have x squared minus 2x minus 15. So I'll factor that into x minus 5 times x minus 3. Okay. Times x plus 3. Now that will give me negative 2x in the middle. And then the bottom, that one's a little tougher factoring. I know it's going to be 2x and x. Okay, then I need to multiply to -9. So let's just say we use -3 and +3 and see if that works. If not, we'll change it. So that's 6x minus 3x. Nope, that was good. All right, so once you have the bottom all the way factored out, now you can actually identify your restrictions for that one. So 2x minus 3, when does that equal 0? We can look at that. So 2x, I'll just do that over here. So 2x minus 3 equals 0 if we add 3 and divide by 2, when x is 3 over 2. And then x plus 3 equals 0 when x equals -3. So those will be our restrictions. Okay. And now if we can do any sort of canceling, we will. I see we can cancel out the x plus 3's. And so our final simplified answer for part B will be x minus 5 over 2x minus 3. So that's the answer, and plus we have the restrictions to go along with it. All right, and we don't really have a lot of room for C, but I'm going to try to put it on the side here just so that you can see it's kind of an interesting case. Okay, so for C, let's start it up here. For C, we have x cubed minus 9x. And so what I'm going to want to do first is factor out an x. So I have x squared minus 9. And the bottom I have 3 minus x. Now the top can actually be refactored because I see a difference of squares. So I have x times x minus 3 times x plus 3. And on the bottom, I actually have 3 minus x. So at this point, I couldn't identify my restriction because the bottom is all the way factored out. It didn't need any factoring. And so 3 minus 3 is 0. So I do know that my restriction is x equals 3. But now this one doesn't look like it simplifies because x minus 3 does not cancel with 3 minus x. So what we could do for this one is we actually could multiply the top and the bottom by a -1. And if we do that, that just makes the top negative and it also makes the bottom negative. But what it does to the bottom is it turns it into -3 plus x. So -3 plus x is the same as x minus 3. Okay, so as long as you have the negative on top, you're good. So now the x minus 3's are gone. And we actually end up with -x times x plus 3. And that would be our final answer. And then, of course, our restrictions are written there as well. Okay. So on the next page is where we start getting into actually multiplying and dividing expressions. And if you know how to simplify, you'll be able to multiply and divide without too much trouble. So this page is really all examples that I'll do in class. So what I want to do is try a couple of try these. Now with multiplying, remember when you multiply fractions, you multiply numerator times numerator and denominator times denominator. Okay, so what we're going to want to do, of course, before we try to do any multiplying, is you're going to want to factor everything. Okay, so that's what we're going to do first. So in part A, I'm going to start by factoring the numerator, which is 2 times x plus 2, and on the bottom, that's a difference of squares, so x plus 5 and x minus 5. So now I have that fully factored. On this side, same. Let's see, multiply to -50. Let's try x minus 10 and x plus 5. Double check that your factors are correct. And on the bottom, I have 4 times x squared minus 4. So that's going to be x plus 2 and x minus 2. Just save a little time by remembering that that x squared minus 4, of course, refactors. All right, well, we can get all of our restrictions now because we are all fully factored. So I see restrictions of, in the first quantity, I see -5 and +5. I also see in the second quantity -2 and +2. Okay, so now we have all of our restrictions. These are all the numbers that x cannot be. Now we can go ahead and do any simplifying. So we'll do some canceling. And so anything on top that has a like factor on bottom can get canceled. And so if I look at my x plus 2 on top here, I know that that can divide out with x plus 2 on bottom. So those are gone. Okay, and I know that I have an x plus 5 on top, so I'm going to cross that off with x plus 5 on bottom. Now I also have a 2/4 that can be simplified. 2 goes into 2 once, and it goes into 4 2 times. So I think I'm ready for my final answer. So my final answer for A, across the top I have an x minus 10 still. Everything else was canceled. And across the bottom I have a 2, we'll write that in front. I have an x minus 5, and I have an x minus 2. Okay, and that will be the answer to part A. So that's how you do a multiply problem. Now when we do a division problem, it's very similar, only if you remember, we don't divide fractions, we always multiply by the reciprocal. So the first step you're going to want to do in this problem would be to flip the second fraction. So let's go ahead and take our first fraction, which is 6x squared and 3x squared minus 27, and write it as a multiply of x squared minus 2x minus 3 over 2x plus 2. Okay. So flip it first. And now we're going to do our factoring. And once we have it factored, we can think about our restrictions. Okay, so let's go ahead and we'll write it over here. So I have 6x squared, that stays, and then I'll have 3 times x squared minus 9. So 3 times x squared minus 9 would be 3 times x plus 3 and x minus 3. And then on the other side, I have on top, let's see, that looks like it's going to be x minus 3 and x plus 1. And then on the bottom, GCF, 2 times x plus 1. All right, so we have some restrictions now, and our restrictions are actually going to come from 3 places, okay? Because there were 3 places where there were denominators, okay? So, of course, there was the original bottom of the first fraction. There is the new bottom. And then what was the bottom? So you actually want to look at all 3 places for restrictions. A lot of them repeat though, so it's not really a big deal in this problem. So our restrictions are going to be, I'm going to put that down here so I have room. So we know that x cannot be a bunch of things. It can't be -3, +3, and it can't be -1. And I think we covered all of that in all 3 spaces. Now when we simplify, we can start crossing things off. So let's see what we can cross off. I've got x plus 1s that are gone there. I've got x minus 3s that are gone there. Oh, and then on the bottom, I actually have 3 times 2, which is 6. So that'll cancel with the 6. And it looks like we got this whole thing down to x squared over x plus 3 for our answer. And then, of course, our restrictions that we found first. All right, so that's just a few examples. Some simplify, some multiply, some divide, and we'll do a whole lot more in class. But you can certainly feel free to start trying the practice now. Have a great day.